Can you guys hear me? Welcome to our panel discussion. So as we done in London in March, it will be we're kicking off the presentation or the panel discussion with a couple of slides to really provide some flavor what it's all about. As you can see from the title, it's about combined heat compute challenges and opportunities coming through AI within the data center industry. Yeah. But before we going really into those slides and then in the discussion, let's have a quickly round with my beautiful people here from my panel, my panelists. Quick introduction, where we're coming from, a bit of a background. We look at some slides and then we have some dedicated really questions. And also, please, if you have questions, feel free to share those. And of course, we're allocating 5 minutes afterwards, so really to be ready to answer all questions coming up throughout this presentation. So I would ladies first as usual. So Isabel, a few words about yourself.
Yeah. Hello everyone. My name is Isabel Kemlin, and I work for a company called RISE, which is Research Institutes of Sweden. So we're a stately owned company that support industry. Well, we're the link between the universities and the industry. So very applied research with our team up in northern parts of Sweden. And we do have a facility 1,000 square meter where we do plenty of tests, a lot within cooling right now. I'm also vice chair of the Swedish Data Center Industry Association.
All right, David, please. Yeah.
Hello. My name is David Gulnazaryan. I'm an independent consultant from Impleon. We are focusing on open source solutions for data center decarbonization and heat reuse.
Yes, hello. My name is Henrik Børling. I come from a company that you might know. It's called Huawei, and it's a Chinese company. I work in the Nordics within the data center facility industry. One of the things I also work with is standardization. So I represent Denmark in the for the EN 5600, and I'm part of the global committee within the ISO standard that is 30134 and 22237.
All right, Deborah.
Hello, I'm Deborah Andrews from London South Bank University. My background originally is product design, but I specialise in sustainable design and manufacture and circular systems. So in addition to working a lot with the electronics industry, I've worked with the data centre industry and research projects for 10, 12 years and was the academic lead for a big European funded project, SEDASI, developing a circular economy for the data centre industry.
Perfect. So and last but not least, so I'm not important, I'm just doing the facilitation here, but I'm also an independent consultant, and like David and myself, possibly some guys of here know that, but David and myself, we have been leading the OCP EMEA community for more than 4 years, but now, of course, in January we resigned the role. There are new people now leading the community, as we decided to free up some capacity now for more consultancy work. All right, so before we go into the discussion, as promised, let's have a look at some slides. Those of you who joined the London one, you can see from the movie Titanic, the tip of the iceberg. It's only a small percentage, and as you all know, when it comes to the carbon emission, our industry, the data center industry worldwide, is producing 2% of the greenhouse gas emissions. But when it comes to the truth and the transparency, again, it's the tip of the iceberg, but under the sea level, 90% of the iceberg is. And when we translate this, and we're using this picture to have it more tangible, translate it into the scopes 1, 2, and 3. Scope 3, and as you all know, this is making 90% of the CO2 emissions in the data center, is a big challenge of this decade to reduce the Scope 3 emissions, which is hiding under the water at the moment here in this picture. Quick one, and we would like to really briefly look at these slides and then go into the discussion. we working on, as we said, open source on all levels, really starting from the server, on the rack level, on the, let's say, modular data center level, containerized data center, until an entire ecosystem for data center, where you are also making use, and this is what it's all about, making use of the excess heat from the data center, yeah? Okay, again, really briefly, for those who would like more information, again, we can really have a discussion afterwards, or you can look, if you go to OCP, I've done a similar presentation in Lisbon at the regional summit of the OCP, but here just briefly, the comparison between an air-cooled traditional server and a liquid-cooled server when it comes to the facility water used. So if you look at the legacy server there, it's 25 degrees airflow is really used to cool down all the components in that server, provided by the 20 degrees the water cooling facility in the data center side. And at the same time, when it comes to the new generation of AI servers, you're possibly aware that the energy consumption just for the internal fans in those servers can rise up to 35%. At the same time, if you look at a liquid-cooled server, there really, when it comes to the inflow of the liquid, it can be by 40 degrees, and this is really ideal to handle the heat rejection from all components, and this is providing excellent conditions, or good conditions for making use of the excess heat there. This is just a link. We are not playing this video again due to timing, but please, if you want to have more information, and we have the expert here, Deborah, when it comes to circular economy, how you really what is as like a building block, running data center size as sustainable as possible, is also using circular economy gear. So extending the lifetime of servers. Yeah, so there are some companies who are really recognizing that's also a business model where servers are decommissioned by the hyperscalers and after 3 years or 2.5 or 3 years, and they're using this, it's refurbished, and they extended the lifetime of these already produced servers, and the CO2 emission has already been consumed by 8 to 10 years. They're running then in medium size or smaller size data centers. Yeah. Quickly, as time is running, here's a comparison really on the space. Comparison, let's say, a traditional legacy air-cooled rack. Oh, I can see there's a slight of a mistake. I need to apologize. So this air-cooled rack, the threshold is 15 kilowatt, but then the liquid cooling one is up to 100 kilowatt. But if you're comparing the space needed for those two different models, let's say the traditional one, you can see 15 cubic meter, because you need space in the front for the cool aisle, and the back for the hot aisle. Underneath the ceiling, you need space for the raised floor. For the raised floor, and then for the ceiling. So all in all, 50 cubic meter, and you can see it's three times more, but the density is 7 times more from the liquid cooler in comparison to the traditional air-cooled one. Okay, and this is the last slide I'm sharing, then handing over to David. So this is also briefly comparison, and here we really comparing apples with apples. So you can see at the one side there is this traditional co-location side, tier 3, tier 4, with 130 racks, yeah, and at the other side it's 26 racks, liquid cooled, and they're providing the same compute, yeah, the same IT workload, and we're comparing the same performance here. But you can see here, you see the traditional one, you have the air chillers, you have the normal chillers, you have water towers. They consuming, just for the IT workload, 800 kilowatt. Yeah. In comparison, the other model, and there are no fans. Yeah. They are just heat pumps or pumps and dry coolers, and this consuming 400 kilowatt. So all in all, if you compare these two models, 1.2 megawatt less is consumed but the performance is increased by 40%. So as a consequence, if all data center sites would switch to liquid cooled, the performance can be increased by 40% with the existing energy infrastructure. So the energy grid do not need to be changed. All right. So I hand the clicker to you, David, and please you continue.
Yes, thank you, Stefan. So in this case, you see OCP AI dedicated server with a GPU, which was tested for 1 kilowatt GPU each, and this is the possibility to make transition from air cooled to the liquid cooled. So the flow rate remains the same, the difference in the temperatures. So we use the same design. And this is about the space. So on the left side, on the right side, you see a 90 kilowatt module, where is bottlenecks air cooling devices. And on the left side, you see 16 racks, which can be up to 18 megawatt. So this is a 20 times denser. Of course, there is issue with energy systems to put in the same space as 90 kilowatt, but there exist already such solutions. But that show how dense can be data center and how can we decarbonize that and make heat reuse. So about the heat reuse, the traditional approach that we take all the energy from the grid, make IT process and reject that on the ambient air. And at the same time, we use fossil fuel to heat up the buildings or other applications. And again, we use fossil fuels and reject the CO2 emissions to the ambient air. In the case when we reuse the heat from data center, we substitute fossil fuels and we reduce our thermal pollution to the atmosphere. And in this case, we get really circular economy approach. And in addition, we also provide open source solution for heat reuse. In this case, it's a fish farming with greenhouses, which allow you to convert thermal energy to valuable product for the local cities to have fresh fish. And Christian Belady from Microsoft in this video is saying that data center should provide land instead of taking land, should provide water instead of taking water, and provide energy instead of taking energy. This is why data centers should come there where are users of the heat. And in order to realize that, we create open source modular underground data center, which can be placed in center of Frankfurt, Paris, Geneva, in order to not take the land, provide the thermal energy close to the users, use less, having less temperature losses, having less pumping energy, and yes, you can see that the capacity of that center can be from 45 to 165 megawatts. Thank you.
Thank you, David. Thank you very much. So, let's start with the discussion. And as usual, if you don't mind, I would like Deborah really to start. And it will be like a controversial discussion, yeah. So, Deborah. So, as you know, when we are all aware that, let's say, high performance computing, AI applications is increasing really the capability when it comes to compute. So, due to your expertise and your specialism at the university, what is really needed to really, when it comes to the design of these servers we have seen, what needs to be done in order to minimize the impact to the environment?
Okay, so a lot of people think that the circular economy is just about recycling at end of life. That is absolutely critical. But we have a massive problem in that we don't have anything like the infrastructure that we need to recycle and reclaim the materials, particularly from electronics. So what we need to do is to embrace many other aspects of the circular economy really thoroughly, and they basically include reuse and repair. And one of the challenges is to make sure that the design of servers facilitates that, well, servers and all other, networking equipment, all the things that make a data center function. Servers in particular, because they have an incredibly high embodied impact because of the materials that are used, particularly on PCBs, but also because of their relatively short life in service. We need to change the design and stop thinking simply about making a brand new model that looks fantastic, works really well, and is designed for one single life. You cannot replace components easily or swap components between generations and models. And that is the established business model for most server manufacturers at the moment. They need to be encouraged to think about possibly selling servers as a service rather than selling product. They're selling hours of compute or bits, whatever it may be. And the products that are designed can be easily disassembled or repaired. They can be then kept in life for as long as possible. So there are quite a lot of businesses that specialise in second life products or secondary market products, but it becomes increasingly difficult to repair or upgrade those pieces of equipment.
Absolutely.
So it's a really systemic shift. 80% or up to 80% of a product's environmental impact is determined during the design phase. So designers have a huge responsibility to encourage change. And even if the manufacturers aren't keen to do that, designers need to push and introduce capabilities like ease of disassembly and for upgrade, repair and recycling at end of life.
And by the way, so an OCP, let's say an OCP design server, a vanity-free server, you can really replace all parts. This is due to the design by yourself. It's toolless. There's a controversial, but I've done it myself, so I don't know why you say because you can replace the fans, you can replace the heat sinks. So all parts which are maybe be faulty can be replaced toolless. But we can have the discussion maybe later on if you do not agree. But this is also an example. I can see that it can be really replaced, and you can extend the lifetime of those servers. I would, if you don't mind, gentlemen, I would like to continue with Isabel. Yeah. So Isabel, as we all know, AI demands is increasing the compute. So in your view, what is when it comes to will at some point reach the technology will physically reaches its limits?
Well, with the air-cooled, we do definitely see that. Yeah. Because if we look at the servers today, actually the microprocessor is generating heat. The heat flux is like a rocket motor. In only a couple of years' time, that heat flux will be like a nuclear station. And then it is not physically anymore to cool it with the medium air, which is actually a really bad medium to cool with. So then we will definitely see different types of liquid cooling.
Yeah, okay. David, coming now to you. Combined heat compute, I think this buzzword is around since a couple of years. People are talking about, please elaborate in the end of in a really brief answer. What is it all about? Yeah, so people are talking about, but
yes, so heat reuse, it's not new. The first project where I was involved is data center in Finland, in Mansala, in 2013-14. And it was the first hyperscaler which big heat reuse. Until now, it's still working and providing the sustainable heat for the small city. After that, we see again and again such examples in Nordics, in Finland, in Sweden, in Norway. They are pioneer in that because they have another, let's say, socialistic mindset when they thinking about the community. And in other countries, we also have that. One of great of example in Odense, where Facebook make full heat reuse of their data center, but the bottleneck that they create adaptation of their existing data center and not change the overall design to replicate that again and again. However, there exist different models of working with heat reuse. So one of the model, when data center provide free heat at low grade temperature and don't charge anything for that. And there is heat reuse operator which convert that to the high grade heat and charge for that the city. Another business model when data center provide low grade heat and take money for that. This is ideal condition for the data center. And another option when data center itself create high grade heat, provide the energy and charge for that heating company, or not charge and provide social value. So we see different models, but in any case we can evaluate that and develop that together with city which want to be net zero and data centers which want to get the energy and social value.
All right. Henrik, your company doing a lot of the initiatives to decarbonize the industry. I'm thinking about this sustainability report. Can you elaborate here? What is it all about, the annual report?
Yeah, I think this is for the whole company, and that is Huawei joined Global Compact in 2004. Global Compact was actually the group within UN that founded the 17 Sustainable World Goals. And since 2011, Huawei have actually made a full sustainability report as a company. It have been developed since then. It was not that good in the beginning, but I think the reports we have now is actually something that really shows we are developing or also missing in all the goals. For instance, we have a concept we call Tech for All. There we have a lot of CSR concepts. In Europe, for instance, we are making some AI solutions that help, for instance, a lake in Austria where the insects have been gone. So they might take mitigating birds. They are not stopping at that lake anymore because they was doing that when they're passing from the Nordics to the south of Europe. Now we are trying to investigate what have happened there. Is it because of the climate change, higher temperatures? Is it because of the farmland that is come too close to the lake? Every these things. So this is a project ongoing. Another project I can mention is actually we had a project in Norway where we have an AI solution that was trying to distinguish two types of salmon from each other, because there was an invasive salmon in Norway called the humpback salmon. And that was challenging and actually also threatened the North Atlantic salmon very much. In the past, when the Norwegians, they fought this humpback salmon, they used 1,700 hours a year, and they found about 1,700 salmons. So that was one salmon per man hour. Now we have made an AI solution that can actually automatic, in a very friendly way, guide the unwanted salmons to an artificial lakes, and that we have done in one river, and there we have put out more than 6,000 salmons in 1 year without any working hours. But it takes some time to build this kind of AI to have it running. The aftermath was that we have a huge amount of data, and this is what we are going to discuss. How can AI solutions be integrated in data centers? How can we use this huge amount of workload also to control data centers and their energy consumptions? I think we'll talk about that.
Perfect, Henrik. You answered already question number 2.
Yeah, in time.
Yeah. We did practice this, man. Anyhow, so let's come back to Deborah. So Deborah, we all aware, we learned already now from the conversation, AI, the high performance applications in the data center sites is increasing the energy supply. Now when we go back on the server level, when it comes to the design of that, what is really needed in changing from a linear to a circular model, to also working on the compute, making use of the excess heat, and to decarbonize the industry.
So I've already mentioned that we need to make servers fit for a circular economy. The design must be fit. It must encourage easy disassembly for upgrade, for separating components, etc. But also other things really, really important are dematerialization, which is basically not using more materials than you need, making products that are durable, but reducing the amount of embodied materials. Now, we, for example, in the Sadasi project, we designed a server that was circular fit, and it's published on the OCP platform. And we managed to reduce the overall mass by about 33%, and that was mainly due to using less embodied steel, particularly for the chassis, for example, but also reducing the number of fixings and so forth. But the big thing we need, and I think design is has a real advantage in this way, in that we need to think not just about designing for now, but for designing for the future. So and that affects material selection. So I think all of you are aware of the challenge that plastics present, not just the fact that plastic bags end up in the ocean, and we've got microplastics in the atmosphere, but also the fact that many plastics, they are brilliant pieces of engineering and sort of scientific discovery. They are designed to do very particular things very, very well, but they're not designed to downgrade or decompose at end of life, as we know. So therefore, when we're making choices about material selection for components in a server, we need to think, is it possible, instead of using plastic, which is very difficult to recycle and to reuse for the same product because they downgrade during the recycling process, is it actually better to use metal, which may be heavier, but the metals facilitate recycling very readily. And in many instances, particularly for anything with iron in, so steel, copper, aluminium and gold, there is already a very, very well-established recycling infrastructure. So that, we need to be a lot more proactive in terms of thinking about the future, but also thinking about things like heat reclamation and reuse.
Yes.
It's, fantastic opportunities if you're building a new data center out in the countryside or wherever, which is pretty controversial unless you build it underground. But then it's easy to develop heat reclamation infrastructure to feed into, hospital, swimming pool, fish farm, whatever it may be. We really need to be very careful about disrupting the existing infrastructure in cities. Is it economically advantageous or not to dig up a whole part of a town simply to put in heat infrastructure, if you like, from a data center? So we need systemic thinking for situations like that.
Isabel, what kind of technical solutions will we see really moving forward?
Well, I think first I would like to just comment. We actually also did a study on a full system LCA, and it was not the carbon that, well, of course carbon is super important, but gold.
It's massive,
gold is a rare metal that we really need to be careful about. The other thing I think is important with the system thinking is from the IT and the facility teams need to work more closely together, because what we have seen from, for example, a technical solution that we have been testing is what we call holistic cooling. So normally a cooling machine is set to a set point of a temperature in a room, and it's a set point. It's not here, or here. It's just a set point for that room. But it's not the room that we want to cool. It's actually the chip on the servers. So we have been doing tests where we combine the steering with the fans of the servers. We have been looking at also the sweet spot of a server. when does a server actually run at its best? You all know that I guess we all would love a car to run at its sweet spot when we go, full speed ahead. But the little economical sign is flashing much earlier. It's the same with servers. So if we actually can look at that and make the combination and steering defense of the servers and combine it with defense in the cooling machine. So when we have done tests like that, it was like magic, because going into that room and turning on that, the whole sound was like, ew. So a lot of energy efficiency were gathered just by thinking more in a system that Deborah was mentioning.
Yeah. Okay. David, coming back to you. What happened really in the last years, which had an impact on data centers, changing a bit also their mindset and the way of working to really look at the heat reuse or making use of that?
Yes, so I will highlight three main things. Yeah. The first thing is energy crisis. Yeah. Energy crisis stimulates to find out the more sustainable source of the heat. And this is why a lot of attention for all possible heat sources which can substitute fossil fuel-based boiler houses and other things. Second thing is the legislation. Mm-hmm. We already see in Germany legislation which requests to do 10% heat reuse from all data centers, which is more than 500 kilowatt. And now the legal department of data centers push on the physical infrastructure to be compliant with this legislation. And the third thing is a new generation of the servers, which already come with liquid cooling, which already can provide high temperatures for heat reuse, and this is going hand in hand with heat reuse. So all that together stimulate to create new model of the data centers, which will fit for that new conditions, new environment. And that will be, of course, not come fast, but we see the huge demand of AI data centers, and this is why there will be a new generation data centers with high temperature and in big scale. And it can come unpredictably fast. Yeah.
So Henrik, of course, we heard from David, there is a change in legislation based on the European directive from the European Union. So countries are now changing the legislation, really giving a framework, really making use of the excess heat. And there are and many European countries there are really some projects. Can you share in your home country? There's a dedicated project going on in the municipality of Varde. It's the energy hub, and the big buzzword is their sector coupling. Can you share with the audience what is it all about?
Yeah, that is because now we see data centers, and we don't need to look at the data centers solely. Try to look at data centers as part of an ecosystem. And this is because in the past, data centers was focusing on where you have the energy and you have the connectivity. Today, we see that data centers are moving in some other direction. They move actually close to consumers where they can reuse the energy, for instance, for district heating. In Denmark, we have Microsoft. They are building 3 data centers in the outskirts of Copenhagen. Another part is we have also this grid stability. We call it the Nordic Initiative Challenge. And this is a challenge, especially in Denmark, because we have actually a lot of solar farms and windmill parks. But the problem is we cannot produce energy as we want to consume it. So therefore, we need some of the big consumers to be part of making this stabilization. This is why we look into data parks. That is parks consisting of more than one data centers, because there we can have a hydrogen production where we actually use excess electricity from the windmill parks, solar parks, that normally would not have been produced, because at the time we have a lot of wind and solar, we don't have the consumption, for instance. So there we can convert it to something else. There's also another part of it. So this is an ecosystem where data centers take part of it. So we can call it like a power as a service for multiple data centers. This is what we take. There's actually a new regulation in Denmark that says if you have a windmill park or solar park within 5 kilometers from your site, then you're allowed to take that as directly connected to the grid. You don't need to pay for the distribution. This is something that the government has made to force also to look into local power. So we say data centers in this way work like bring your own power to the site. So this is one part to look at it.
Perfect. So this is something also for the audience to really to watch. I think this is an excellent example how to decarbonize the industry using data center sites, which at the end of the day are power plants. And we as an industry, we have the tendency to only look at what we are doing, but this is really using data center sites as anchor to also attract other industries and really using and working together and using, let's say, the excess heat or the thermal energy to also produce green hydrogen. So this is how I think a great example. And please come back to Henrik if you really fancy more information about this project. Coming back now to Deborah. Deborah, yeah, we can see here there are some needed with many changes are needed, and what kind of changes are really needed to really minimize the disruption of the industry. In the end of the day, what kind of services are really needed and products really on the short and the long term in your view?
Okay. So again, I'm you probably realise, a great advocate of systems thinking. But the data centre industry, it has grown at a speed and scale that's been absolutely unprecedented in human history.
Yeah.
But it's all been about life in service and service provision. And anything, when equipment's taken out of service, invariably it becomes someone else's responsibility, not data center operators. Stuff is either donated or sold or paid for, collection, whatever, and it's someone else's responsibility to either extend product life or recycle it. And I mentioned that we haven't got a recycling infrastructure that's fit for purpose anywhere in the world. There's a lot of very hazardous and unregulated recycling of things like copper in Ghana, for example, where cables are literally in the plastic housing is incinerated so that the copper can be extracted, and that is done by young guys wearing T-shirts and flip-flops in the open air, which is great, but PVC is carcinogenic, it's toxic when it's burnt, and also you've got greenhouse gas emissions being produced. So there's a lot of unregulated recycling. We need to somehow increase recycling capability. And it's a brilliant opportunity for data centres to diversify, the organisations to invest in businesses that extend life and recycle, and to also support research into reclamation of some of the sort of 50 or 30 to 50 materials recognised, that are critical for the industry that at the moment they are not being reclaimed. So critical raw materials, there are 30 to 40 that are recognised in the EU as being of technical and economic significance, but they just vanish in the mainstream recycling. And if we don't invest in proper recycling and reclamation capability, we're going to end up with a material shortage, a threat to the supply chain. We've already seen instances of disruption during COVID, chip production, etc. That will only become worse. So please persuade the big players in the industry to start thinking more systemically and invest in aspects of the life cycle other than just operation and service provision.
Yeah. Mm-hmm. So, coming back now to Isabel, and I think that we have some minutes left there, 5 minutes left. Quickly elaborating a bit on the legislation we already said is changing based on the directive from the European Union when it comes to the energy efficiency. Some countries are picking it up, so this time the Germans are first to have it in their country law, or have it really effective since the 1st of January. We have controversial opinion, but please share what you think about when it comes to legislation. What you think about which has an impact not only on the data center industry but at all industries.
Yeah, so the Energy Efficiency Directive is something that has been there for quite some time, but now it's actually one piece that is directed to our industry. And last week, the Delegated Act was published, and it's not a delegated directive. It's a delegated regulation, which actually means that everyone that has a data center space more than 500 kilowatt need to start to report directly to EU if it's not set up a system in your local country. In Germany, there is. So Germany went ahead and have already put, well, I will go back a little bit, because the intention of the EU Commission was to start measure, to start to understand what KPIs that are good for our industry to actually reach the overall goal as in energy efficiency. They wanted to start to measure and then see if the KPIs were good or not, and then actually set limits to them. What's happening in Germany, and actually now also in the Netherlands, is that the regulation is already there. So in Germany, there are levels for PUE. There are levels for how much you need to reuse your heat. And if you're not able to do it, you will get fines. So since the PUE is maybe not the best one, especially if you're using a heat pump, they are reviewing the PUE right now, I know, from an ISO perspective. But the way of doing this with going out with a stick in Germany, then maybe instead of the EU Commission's intention of having a good scoring for green investments, so that investors actually would see where they would put their money. Yeah, that is a ways that have been chosen here in Germany. In the Nordics, we would prefer the carrot.
All right, we're running a bit of time, but David, please share what are the challenges when it comes to combined heat compute and how to overcome them, and as possible, as brief as possible.
So first challenge is the size of the data center and size of the heat reuse customer. So we need to make right size, which fit one to other. Another thing is to find the right way of heat reuse. It's not only heating. There is much better opportunities in Middle East by making desalination, which is round the year and then huge scale heat demand. And of course, another challenge is education. So all the data center industry, and not only data centers, but also city government and etc., need a lot of education. Education is the first challenge.
Okay. All right. All questions from your side are gone, Hendrik. Just have a quick round, really as brief as possible, only, let's say, 1 or 2 sentences, sharing with the audience, in your view, from your experience, what is the game changer supporting the industry, helping the industry to decarbonize it, and the audience should really have a look at in the next coming years? So maybe Isabel, you start.
Yes, so I think the game changer is system thinking that we have been touching upon. System thinking within the data center between the IT guys and the facility guys.
Yeah.
That's key.
Okay.
Yeah.
Maybe Deborah?
Don't just follow legislation. Be proactive, lead. So don't just think about reducing carbon. think about reducing impacts right across the sort of materials and surface spectrum. Isabel mentioned that gold has a very high impact. Gold mining is one of the most toxic activities that we undertake. But if you're just looking at carbon assessment, all of that is excluded. So think bigger.
Henrik, please.
I will go back to the standards, and I will really pinpoint the ISO standard 31134. And the reason I want to pinpoint that is there's two factors there. There's actually 8 KPIs there, and this is the KPIs also where EED and Climate Neutral Data Center Pact, they have used some of them. What I don't understand, why not use all 8? It's so stupid. We have an ISO standard, why not use it? But in this standard, there's 2 KPIs that actually goes to the active equipment. That's for servers. So it is servers utilizations and the power factor for servers. And this is what I really also want to empathize. We are making really big demands for the data centers. Why not also make some demands for the customers to help the data centers run the data centers more green than they have already? That means that you actually can't do that if you use the ISO standard. Because when there is a green energy available, why not run your servers at the full speed because you can? Mm-hmm. When there is no green energy available, why not postpone some of the jobs? And the same way with the heating system. We know that if you use heat recovery, you cannot use it all the time. But let the users help the data centers to recover as much as possible for it.
All right. David.
AI change everything.
Okay, perfect.
I have one more.
Okay.
That I promised you to say.
Okay.
And it's actually, where should you place your data center?
Please go ahead.
Yes, so once upon a time, you know all that there were some Vikings. And where did they establish? They established where the communication was good, where the rivers met with the sea. The same with data centers. So where the power lines means with the internet cables, that's where the big data centers are establishing themselves. And this was what was the topic I used to say before COVID. But now the third dimension here is the reuse of heat. Yeah. So power cables, internet cables, and where can you reuse your heat?
Perfect. I think this is a really good final statement. I think we are a bit over time now, but straight away, are there any questions here from the audience to this beautiful panel here? A gentleman over there, please.
Hi, Stephen from Castrol. We look after liquid cooling. And one of the questions I had for Henrik is you mentioned a lot about kind of biodiversity and some of the initiatives that Huawei is doing as well. The panel mentioned a lot about liquid cooling designs. Is that something that you guys are working on? And if so, if not, what are the key barriers here to make something like that happen for you?
Yeah, we are working at it. Can you hear me? Yeah. We are working at liquid cooling. Actually, we've done it for some times. I'm not part of that division, but we have our data customers, Huawei Cloud, and they have worked hugely with liquid cooling for actually many years now. But the changes we see for this stage is how to make the cooling systems modular and scalable, because a lot of different systems will run there now. So this is our way to go for it now.
David, you want to elaborate, or you're happy?
No?
As a liquid cooling guy?
It's not enough time.
Okay. There was a question over there. Yes, please.
Catherine Brandel from Infineon. One question to Isabel. It sounded a bit like the PUE, and I heard that now a couple of times is maybe not the best KPI to measure the energy efficiency. In your opinion, why is it used so much, and what would be a good alternative, or is there a good alternative?
Well, the good $1 million question.
Sorry.
Now one thing is definitely the reuse of heat factor. That gives a much better picture, but I think it should be used in combination. And why I was saying that PUE is not always that good, because it depends on, for example, if you have a what's the name of it? Heat pump.
Sorry.
If you have a heat pump, and if it's on your side or if it's on the electricity side, then your PUE will be totally different. So I think we need to look at the overall picture of the energy heat reuse.
Thank you.
Sorry, guys, we need to stop. If you have further questions, we are still around here, also straight after the panel now, because there are more people now also would like to share something here. Many thanks for your attention. It's appreciated. Again, we are still around here a while. And also, if you have questions later on, drop us an email or get in touch with us via LinkedIn. We are more than welcome to have a detailed conversation with you on that topic. Thank you very much. It's appreciated. Thank you. Applause for the panel. Thank you, guys.
Thank you.
You're too good to be true.